love to give the audience a chance to ask maybe just one or two questions to our presenters from this session. Are there any questions? Okay, there's a question here. Do you mind going to the...
Great presentations. I just had a question because we've heard about nuclear energy and we heard about hydrogen. So how do we compare the two? Like which one's better? Is a difference in efficiency, cost? Like what's, yeah.
Okay. Yeah, I mean, regarding the comparison between the nuclear and the other sort of energy, okay, let's talk about the renewables. So, is this a question, yes? Hydrogen, okay. Hydrogen, the thing is that, for example, relating to my presentation, the Craigie's project, the demand in the Caribbean is small among these different states. It is predicted that the extra or the surplus of the energy produced from the renewable resources, like the wind, offshore wind, or from the geothermal, should be shared with other states. And still, we are talking about gigawatts. So this is hundreds of gigawatts. So this is too much energy quantity. And this will be mainly used in order to produce green hydrogen. And then green hydrogen will totally change the economy of the whole region in this case, because it will be the commodity of the future. So, and in addition to this, that the European Union are imposing something called CBAM, which is a carbon tax. So if you do not produce green, if you produce brown hydrogen, they will not take it. Nobody's going to buy it, and you're going to pay taxes. If you're producing green hydrogen from renewable energy, so renewable energy and hydrogen, green hydrogen, they are complementing each other. They are very important to each other. Nuclear, I believe that you can maybe add further to the subject if needs to be more. I mean, thank you.
Panelists want to chime in on that?
Yeah, I'm not a nuclear engineer, but I've been working, I know more about nuclear than I ever thought I would over the past 6 months. And largely our focus is, and we're working on some hydrogen projects too, and we're just focused on the application. So with transport, hydrogen is lighter and doesn't make sense to use batteries for long hauls. So the application suits the technology. And in case of nuclear or nanonuclear, we're looking at mining scenarios where we're trying to prove the business case of a mine. It's a 5-year period. Our refueling cycle for a nanonuclear application is 5 years, whereas diesel is delivered weekly, and it takes 7 liters of diesel to deliver 10 liters of diesel to one of these sites. So that the application, that's that kind of product market fit that we're focused on. It's more the business case in the market aligning with the technology benefits.
Just wanted to add one thing about nuclear. Nuclear technology is excellent, and it's fine, everything, as everybody saw from the presentations, from the can-do type fuel and the compact size and the various type of uses and applications. Unfortunately, in the case of the Caribbean, because it's small states and they don't have the much demand which could be produced from SMR, which is the small modular reactors, plus I will not talk about the community projection and all of that. I mean, objection on how to use the nuclear reactor. This is not the case. But if the Caribbean states wants to finance any of the nuclear projects, they have to go to MDBs, the multilateral development banks, like World Bank, CDB, and others. There is no MDB in the world, starting from the World Bank downward, is financing anything regarding nuclear at all, whatsoever the quantity, the location, or the price, unfortunately. Although it is very effective and it can be a good solution for many things, but it's not, I mean, it needs money, and we heard that it's several hundreds of millions. So for a specific smaller demand, and I think there are many other type of solutions which are less expensive than that. Thank you.
Yes, Dr. Asamer?
Well, I would assume, like, I'm an urban planner, actually, city and regional planner, working in energy efficient urbanism as well as regional planning. And I've been working on different types of alternative energy applications on different sectors. Today just was about the logistics sector, but I'm also interested in the housing and mobility and other sectors as well, and how actually the renewable resources can be applied on these sectors. And as far as I could see up to date, like involving with 20 years of experience, I can see that this energy issue is about spectrum. So depending on the geography, depending on the legal framework of that, region, depending on the climate change effects, because not everywhere has the same effects of the climate change. Sometimes some parts are experiencing heat waves, but some of them are not. So depending all kinds of parameters, including the human resources, which is very critical, I believe, in terms of safety and risk, regulations. Well, for instance, McMaster might do really great job here, which is great, and we are proud of that. And I'm also a Canadian as well as a Turkish citizen, and I'm really proud of that. But I'm very curious about that technology. What if it was in somewhere, in a developing country? I wouldn't be so feeling safe, unfortunately, depending on the human resources, all kinds of. I'm not trying to accuse anyone here, but it's just the reality of the world. Places are not same. So that's why when we're talking about energy efficiency as well as transition process, we need to understand different dimensions, and we need to have a plan according to what fits to that body. So tailored, projects are, I believe, critical in terms of adapting. And sometimes you may have mix of it. Sometimes just only one. So that depends on the situation, I believe.
Thank you. That's, I think, a really important insight. Now, I'm going to take moderator privilege here and ask the last question for the session. And I want to give our two PhD candidates an opportunity to speak maybe a little bit more about their research, building off of what was just said about the use case and the context of technology. So I'd like to hear from you, the two of you, about where do you envision sort of the application of the research you're doing now?
Thank you for that, Kina. I think with solid oxide fuel cells, one thing that I've come to realize while researching it is that it can be applicable in a wide range of different industries and different scales. So what I'm doing right now is basically finding data that could help us model or even predict the performance even better and see how it could be coupled with other energy systems. So in conclusion, what I'm saying is that in the near future, what we could be seeing is more diverse energy generation methods where we put in not just your conventional grid or not just nuclear, but combining a bunch of them to achieve our desired effect.
Fantastic. Vishal?
Thank you very much. So my research based in catalytic pyrolysis, while it's still experimental, it is one of the ways of producing hydrogen and reducing the amount of carbon. Now, my country, Guyana, is one of the now booming oil nations, but we still flare all the natural gas. We see that the most common method of producing hydrogen is steam methane reforming. But catalytic pyrolysis of methane, which has been researched, produces less than 1 kilogram of carbon dioxide per kilogram of hydrogen. So, so my research is based back home. We're having a gas to shore project where we're going to burn natural gas to produce electricity. So producing enough electricity as well as producing hydrogen, we can also become an exporter of hydrogen. So I'm hoping that my research pushes us in that direction of having the region become an exporter of hydrogen at some point between now and 2100. because it affects both or influences different sectors, because hydrogen is used in ammonia sector, can be used in the for fertilization. The byproducts can be used in agriculture as well as in aquaculture application as well. And machine learning can help us bring that design to move it from laboratory scale to commercialization. So that is the hope of the research. Thank you.
Fantastic, thank you very much. And yeah, let's thank our panelists one more time.